Continuing on with 5.3, we are in example 10 having to do with global warming. In an effort to reduce global warming, it has been proposed that a tax be levied based on the emissions of carbon dioxide into the atmosphere. The cost-benefit equation, see they even use logarithms with global warming. Sorry, I'm taking the time to write this all out. Okay, so there is our equation. It estimates the relationship between the percent reduction of emissions of carbon dioxide, P, as a decimal, and the tax, T, in dollars per ton of carbon. Okay, I really don't care about the whole global warming thing. We just have our equation. We're just going to answer it. Okay, so it says for A, solve the equation for P, the estimated percent reduction in emissions. Okay, so that's all we're going to do at this point, is we're going to solve this thing for P. Alright, so first of all, let's go ahead and write this in exponential form. Let's get rid of the logarithm here. So we have this, 1 minus P, equals, remember my, it's a natural logarithm, so it's going to have E for the base, and then we're going to have this whole kit and caboodle on our exponent. Okay, so we just changed it to exponential form, and now we're going to solve for P. So really all we're going to do in order to solve for P is bring this over here, and now we have a negative P. We don't like having a negative P, so we're going to make it positive, which means we're going to make that negative and that positive, which you can do. If you change every single sign, you can change your negative P to a positive. So there we go. And actually I would take this 1 and put it in front of here, so it would be 1 minus E to that power. Okay, so that's what they were asking for A. B says determine the estimated percent reduction in emissions if a tax of $100 per ton is levied. So for B, all we're doing is substituting 100 right here, and we're going to look for our P value. So that's why we changed it to P equals. So when we wanted to find out what P is, we just put a 100 in here, and we multiply that, subtract that from here, take the negative E value, add 1, and that gives us P. Okay, so let's just go ahead and do that. Let me rewrite this whole thing right here in a correct format, and then we'll go from there. Let me turn this off. Okay, so in blue is what we've got here with the whole formula. When we multiply that by 100, using my handy dandy calculator, we're going to get 0.53, and then when we subtract that, we're going to get 0.0034. We're going to get negative 0.534. So that's what's going on my E. Okay, now I need to get a calculator that will do natural logarithms. Alright, so when I do that, I punch in this number into my calculator, and then on mine, I hit the second function number that gives me e to the x, and that gives me for this whole thing then 0.5866. Okay, so then 1 minus 0.5866 equals 0.4134, which gives me approximately 41.3%. So that's what it will reduce the emissions if I tax people $100 per ton. So anyway, that is number 10. All right, so let's go to sales decay. Sales decay is that time where I had mentioned earlier that when you get done with an advertisement, sales starts going down. Okay, so you have all these commercials on the radio or on the TV for Coke, and after the commercials are over, then sales start going down, and that's called sales decay. Okay, so at the end of this advertising campaign we're looking at, the daily sales of Genepet, whatever the heck that is, fell rapidly, with daily sales given by S equals 3,200 E to the negative 0.08. Come on, give me a T. T, or I'm sorry, that's an X. I'm sitting here trying to put a doggone T in there, and it's supposed to be an X. Okay. Where X is the number of days from the end of the campaign. So if the campaign ended on the 10th of July and it was the 17th, it would be 7 days. That would be your X. For how many days after the campaign ended were the sales at least $1,980? So 1,980 goes right there. And that equals our 3,200 E to the negative 0.08x. Okay? So, all we're going to do now is divide this by 3,200 to get our E isolated. And once we do that, once we're able to get this isolated with an X there, we're going to take the ln. Alright, so this, first of all, is 0.61875, and that gives me my E to the negative 0.08x. I'm going to take the ln of both sides, and when I do that, my ln to the 0.61875 gives me negative 0.4801 with the punch of a couple buttons. And then my LNE right there, from our property of logarithms, is going to give us negative 0.08x. So remember when we did this a while back, let me put that ln in a nice place to see it there. We have ln of E. When we have ln of E, it's just that. Okay, so that's just a common thing. We didn't do any calculations to get there. We just know that ln of E goes away and the 0.08x stays there. Now we can just divide both sides by 0.08 or negative. Those cancel, and we're left with a positive number. When you divide that out, you get a number similar to or approximately to 6. And that's how many days. All right, let's go to cost benefit, and then we'll call this section good to go. Now, the thing that I've said before is you need to remember that these are not just going to come naturally as far as being able to understand which direction to go to solve these. This takes tons and tons of practice, and you're not getting tons and tons of practice. So I'm not expecting you to get this really fast and easy as far as like looking at example 10, knowing that you're going to take the natural logarithm of both sides. Why did we take the natural logarithm instead of just changing it to exponential form? Well, it was already in exponential form, so that should give you a clue. If it's in exponential form, you're probably going to change it to logarithmic form. And if it's in logarithmic form, you're probably going to change it to exponential form. Okay, so it's just knowing how to go back and forth and using those tables in order to get this. Okay, so let's go to cost benefit. And it tells us the cost-benefit equation, which we've already used. And that equals negative 0.0034 minus 0.0053 T. Estimates relationship between the percent reduction of emissions of carbon dioxide. All right, we already did all this, okay? So, what tax will give a reduction of at least 50%? So, what we're interested in doing here is find the value of T that makes P 50% or 0.50 because that's 50% in decimal. Okay, so we're going to replace P with 50%. 1 minus 0.50. Okay? In fact, let's do this. Okay, let's not do that. Alright, so that gives us our negative 0.0034 minus 0.0053 T. So we're looking for T there. Okay? So 1 minus 0.5 is going to give us 0.5, so we'll just take that out. ln of 0.5 easily put into your calculator, and 6931, and that equals, you get tired of watching me write these numbers. I sure get tired of writing these numbers. Okay, gives me that. I'm going to add this to both sides, and that's going to give me a 0.6897 with the negative on there, and then we have negative 0.0053 T. Now I want to change these to positive. I just change them both to positive. Okay. Actually, what I'm doing, just so you know why that's okay to do that, is I'm dividing both sides by a negative. Okay, so actually 0.6897 times negative 1 gives me this here. So if I divide both sides by this negative 1, then my signs change. So that's actually what's happening. I'm not just making something up. I'm actually following algebraic principles in order to do that. So it's not like it's like, oh, okay, let's just make up a new way to do these. So anyway, I have 0.0053 T equals 0.6897. Divide both sides by 0.0053. That goes away. And T is this, which is approximately 130.14. So, that's the tax, $130.14 will give us our answer there. All right, so that's it for lesson 5.3.